Hello, welcome back. In this video, we'll discuss the pumping methods and schemes. In order to create the population inversion in an active medium, the atoms in the material have to be excited or pumped into a particular energy level. To pump the atoms to a particular energy level requires certain amount of energy, and that energy is supplied by means of pumping. So the pumping methods are essentially those methods using which one can supply energy to the active medium so that the atoms in the ground state, they would go to the metastable state. That is the purpose of a pumping method. The most common methods of pumping are optical pumping and electrical pumping. The first one being optical pumping, the second one is electrical pumping. These are the two methods that are commonly used. Now we shall discuss about the optical pumping. By the name itself, one can understand that we are going to use light or photons in this pumping method. The optical pumping method uses light or photons to excite the atoms. In the case of optical pumping, light is used to excite the atoms in the active medium. So we need a light source. We use generally flash lamps. The flash lamp generates flashes of light. When light falls on the active medium, the atoms in the active medium, they will be excited to the higher energy levels, and subsequently a population inversion takes place between the metastable state and the lower energy levels. The photons of appropriate frequency are used to excite the atoms to an upper energy level. From there, they drop to the metastable state to create a state of population inversion. The photons used to pump energy should have higher frequency than the emitted photon. This is because the atoms have to be excited to an energy level that is above the metastable state or above the metastable level. The pumping level of the atoms must be broader levels. Broader level means about the pumping energy level, you should also have several other energy levels. Then you call such a group of energy levels as broader energy levels. The pumping level should span a range of energy levels. If the level is narrow, one can use photons of a particular frequency. Such a situation severely restricts the choice of the source of light, and also a large portion of the source power would go waste. Most of the lasing materials in which the pumping levels are wide bands, therefore light sources like flash lamps emitting broad range of frequencies can be used for pumping. Optical pumping is suitable for laser medium that is transparent. Since we are using light, the active medium should be transparent. The optical pumping methods are essentially used in solid-state lasers. Example is a ruby laser. Now we shall discuss the electrical pumping. Electrical pumping can be used in case of laser materials that can conduct electricity without destroying lasing activity. This method is limited to only gaseous lasers. The electrical pumping scheme can be useful only in those lasers in which the active medium is a gas. Electrical pumping can be employed in lasers in which the active medium is a gas or a mixture of gases. The examples: helium-neon gas laser. In the case of electrical pumping, electric discharge is produced in the cavity. And when you have the electric discharge, you have a current. And the current will be due to the flow of electrons. And these electrons, they possess certain amount of kinetic energy. With certain kinetic energy, interact with the gas molecules or atoms. These electrons, when they interact with the gas atoms or molecules, they transfer their kinetic energy to the gaseous atoms. Essentially, the kinetic energy of the electrons, upon interacting with the gaseous atoms, it will be transferred and used to establish a population inversion in the gaseous lasers. We use the electrical pumping only in the case of gaseous lasers. Now we shall see the pumping schemes. There are two major pumping schemes. The first one is a 3-level pumping scheme. The second one is a 4-level pumping scheme. A 2-level pumping scheme is not possible. Why it is not possible? Because the probability for an atom to go to an excited state and the probability of an atom reaching the ground state are equal. So when you pump the energy, at any point of time you will not be able to attain the population inversion condition between the ground level and the excited level. That is the reason why a 2-level laser does not exist. Now we shall discuss the 3-level pumping scheme. In a 3-level pumping scheme, suppose this is the ground state we are representing with E1 and we are supplying energy to the material, and this energy is coming from the pumping source. When the energy is supplied to the atoms in the ground state, they will be excited to the pumping level, that is E3. The energy should be equal or greater than the difference between E3 minus E1. Under such conditions, the atoms will be excited to the pumping level E3. E3 is a normal state. As a result, the atoms will be spontaneously dropping to an energy level E2, which is the metastable state. Meaning E2 energy level is having a very long lifetime, because of which the number of atoms in the E2 level keeps on building up, while the number of atoms in the ground state, they will be depleting. So we are continuously supplying the energy. The atoms, they go to the excited state, that is the pumping level E3. From there they rapidly drop down to the energy level E2, that is the metastable state. A downward transition from E2 to E1, it takes place, that is a lasing transition, due to which we'll get the lasing. In the 3-level scheme, when the medium is exposed to pump frequency radiation, a large number of atoms will be excited to the E3 state. However, they do not stay at that level but rapidly undergo downward transition to the metastable state, that is E2, through a non-radiative transition, meaning from E3 to E2 transition is a non-radiative transition, meaning energy is released not in the form of light. Essentially, the energy will be released in the form of heat. And this is a spontaneous process. The atoms are trapped at this state as spontaneous transition from E2 to E1 is forbidden. The transition from E2 energy level to E1, that is the ground state, is forbidden. So a population inversion between E2 and E1 is established. The population inversion is achieved only when more than half of the ground state atoms are pumped to the upper state. Thus the scheme requires very high pump power. The 3-level laser scheme produces light in pulses, or it is used in pulsed lasers. So those lasers that emit light in pulses are called as pulsed laser. Now we shall discuss the 4-level pumping scheme. The 4-level pumping scheme is shown here. We have the E1, that is the ground state. We are supplying energy to the atoms in the ground state. These atoms, they will be excited to the E4 energy level, and from there they rapidly decay to an energy level, that is E3, which is a metastable state. And from there they make a stimulated downward transition to E2 to release the lasing. From E2 to E1 they make a spontaneous transition. The lower laser transition level in this scheme is nearly vacant. This one, therefore less pump power is required. The lower laser transition level in this scheme is nearly vacant. Therefore less pump power is required. Further, the 4-level scheme supports the continuous wave operation, for short called as CW mode, that is continuous wave mode. In the case of a 3-level scheme, we have said that the light emitted by the laser will be in the form of pulses, whereas in the 4-level laser scheme, we are going to achieve what is known as the continuous wave mode. In this video, we have started our discussion by stating the two common methods of pumping, the optical pumping and the electrical pumping. In the case of optical pumping, light or photons are used to excite the atoms, and the light sources can be a flashlight. The atoms in the active medium should have the pumping level that is broader. Since we are using light, the active medium should be transparent. Generally, the optical pumping method is used in solid-state lasers. One such example is ruby laser. After that, we have discussed the electrical pumping, where the active medium generally will be the gas. In the case of electrical pumping, electric discharge is produced in the cavity. The electrical pumping method is exclusively useful in the gaseous lasers. a current due to the electric discharge flows through the tube. The kinetic energy of the electrons is utilized to transfer energy from the electrons to the gaseous atoms. Thereby, a population inversion state can be established. We have seen the pumping schemes. There are two major pumping schemes, 3-level pumping scheme, 4-level pumping scheme. A 2-level pumping scheme is not possible. We have seen the 3-level pumping scheme with the help of a diagram. We have said that high powers are required to pump energy into the active medium using the 3-level pumping scheme, and lasers that use the 3-level pumping scheme, they are generally pulsed lasers. After that, we have seen the 4-level laser scheme, and we have said that since the lower laser transmission level in this scheme is nearly vacant, therefore less power is required, and 4-level laser operates in continuous wave or the CW mode. Thank you.